Okay, now on point J, we are telling the Microbeast how much mechanical throw it needs to get some 6-degree cyclic pitch. For that you have to align your blades with a helicopter, attach a pitch gauge like that, and calibrate it to 0. Now you can use the roll stick to adjust your 6 degrees in one direction or the other, doesn't matter. And it's very easy, you just go back and forth until you have your 6 degrees, like that. And then you watch at the color of the Microbeast LED, it is blue, which means that the mechanical configuration of this logo is perfect for flybarless. If you have a red LED, that means that your mechanics need to be changed, because your servo will not be used in their full range and giving a bad resolution on your servo. For that, a first step to do is usually to put your linkage closer to the servo on the horn, giving you more throw for less, more servo resolution for less throw, and you can get happy with this. On some helicopters like T-Rex 600 or T-Rex 700, you have some difficulties because of the push-pull, where you cannot go far enough inside on the servo horn. But right now Align is selling some 3G horns where you have some internal holes, which helps quite a lot. If whatever you do you are not able to get blue, just stay with red, but be careful to have the 6 degree. What is more important are the 6 degrees and the color. The red will just tell you that you are not the best, but it will still fly. Okay, once you have your 6 degree, you can validate as usually pushing the button. So now we are on point K, and you just keep your pitch gauge now to adjust your collective pitch. So for that you use your pitch throw, you go fully in one direction, and you see that now fully pushed down I have only 7 degrees. Now you use the rudder pitch to adjust whatever you want. I like to fly with 13 degrees, so I go to 13 degrees, like that. Okay, now I go the pitch the other way, and in the other way, same thing, using the rudder stick, I can adjust more or less collective pitch, and I go again to 13 degrees here, which makes me happy, and I validate by pushing the button. So now we are at point L, which is your cyclic ring. It's not actually a cyclic ring, it's your limiter of the cyclic servos. So you have to go in the most difficult situations like full negative pitch and full servo, and you can see that here is some binding. So using the rudder you can now add more or less throw to this. It's difficult to see on the video, but with the rudder pitch you can have less throw or more throw. So you have to adjust the throw until you have as much as you can without any binding. Okay? So now you can verify in all directions that you have no bindings. I actually still have some, so I use a little less. Okay, here's my maximum without any binding. I can go in all directions, and I confirm with the button. It is important here to get as much as possible throw to have an agile helicopter, but not of course having any bindings, because in flight the Microbeast can want to go to the limit even if your sticks are not at the limit, depending on some wind conditions or whatever. Next point is now the point M, which is one of the most important, because here you need to have the right compensation for the cyclic. So to test this, you have to bank your helicopter and your swash plate needs to keep horizontal. What you see here is not the case. So you give a rudder stick input like that, and now it changed color on the Microbeast, and you try again. Okay, now it is staying horizontal. Okay, now let's try the other direction. In this direction it is already good. If not, you would have need to give another rudder input. So you can see I can do whatever I want with the helicopter. The swash plate remains horizontal, meaning that you now have the right compensation. And you don't forget to validate once again on the Microbeast. Now you see that the swash plate is banking forward. It could be backward, it doesn't matter, it is just one direction. And this is to optimize on point L the the so-called pyro compensation. So which means that when you turn your helicopter now by 90 degrees, the swash plate needs to stay banked in this direction. Okay, I go back. You see it is always going in this direction, and it keeps this direction if I turn the helicopter, which is a good adjustment. Just to show you, I move to the other point, which is the blue point. And the blue point, now if I turn the swash plate, you can see that it is banking in the other direction than at the beginning. So this is not the right case. I have to go back to red in my case, verify that it stays stable. It does, and I validate. This finishes now the setup, the mechanical setup of the Microbeast. Now we need to adjust the tail gain. It is just like any gyro gain. You have to adjust it on your transmitter. On my DX7 I do it with the endpoints on gear. Moving these endpoints, like here, will activate one or the other LED. So you can actually see how much gain is corresponding to how much percent on your transmitter, which is a quite good feature. Often you don't know. So for the start, the recommendation is to start with light G, which will be a good starting gain. So we are going to the parameter setup. For this you need to push the button, but a little less long, to get to a flashing light, and then you have only 4 points A, B, C and D. So point A is adjusting the fine trimming of the swash plate. If you did the correct trimming of the servos in the previous setup, I think you don't need this point. I personally never used it. Next point is point B, which is a flight behavior. You can here have your helicopter starting from a beginner helicopter, very smooth, not very reactive, to a 3D helicopter. You just need to choose between all these different flight behaviors. The default offset is red, which is called the sport flying. So it will be suitable for many people, but if you want to do some 3D, then it's better to go up to extreme, or what I do myself, go to the radio setup, which is the blue light. And on the radio setup, in this case, you can adjust your dual rates and your exponentials just like you wish. So I put status blue and go to the next point. In point C, we can adjust the pitching up compensation. One of the most difficult tasks of a flybarless system is to have a straight fast forward flight, because of the natural pitching up tendency of any helicopter. So here you need to adjust the value. For the first flight, just stay with the default, but then try to go as low as possible. The lower the better. For that you do a fast forward flight and you pitch up and pitch down quite quickly, and you look if your helicopter stays on the same level. If it is pitching up or pitching down, that means that you have not enough and you need to increase this parameter. If it is staying level, you can try to decrease it as much as possible. So this is a parameter that you need to adjust in flight, but don't worry, the default parameter will already work quite good on most helicopters. Next point is the point D, which is heading hold. Here again you can use the default, and again the less the better. To adjust this you have to do some fast forward flight pirouettes and look how steady is your rotational rate, your pirouette rate. If it is steady you can try less, because again the lower is the better. If you have put too much of heading hold, you can get some jerky stops with some back drifting. So here again for the first flight, just stay with the default. Just to mention that this setups needs to be done only once your gain, tail gain is correctly adjusted. Don't do it first, but this we will see later on the flight tests.